Previously, we talked about superfunctions. As a matter of fact, we talked about the superfunction f plus g, the superfunction f minus g, f times g, and f divided by g. Now, one thing about all of these functions, the easy way to do it was, if we had a number to apply these superfunctions on, we basically plug that number into f, plug that same number into g, and then added the results together. Or, in this case, we plug that number into f, got an answer, plug the number into g, got an answer, and then subtracted. In this one, we plug the number into f, plug the number into g, and multiply the results together, and similarly here. Now we're going to study our next superfunction, which is the composite function. The composite function is written in two ways. You'll see it written as f circle g of x, or f of g of x. And the difference between this composite function and these four superfunctions is, in this one, there is an order to it. I call it a sequential function, because you do not plug the same number into both f and g. As a matter of fact, you only plug this number into g, and then you take the result of it and plug that number into f. To help illustrate that, I have a little drawing. Here we have the function machines. And suppose that we let the function f operate first. If we do, then x goes into f, and what comes out of it is f of x. So we plug the number in, and we got a different number, probably, as a result. Now it's time for g to operate. So what we're going to plug into g is this result of f. So what we're actually plugging into g is not x, but f of x. And then g acts. And what g is going to do, g is going to do its thing, so it's going to be g of it. In this case, it's g of what went in. In other words, g of f of x. So you started with x, f operated on it, got an answer, and then that result plugged into g, and g did its thing. Now, of course, if we change the functions around so that the order is different, the sequence is different, now we have x is going into g, g is going to operate first, that gives me g of x. And now this result is going into f, so x is not going into f, it's g of x going into f, and then the result of it is f of what went in, f of g of x. Now before I show you an example with two actual functions, let's think of the shoes on sock function. In that idea, if you have shoes on socks, you're going to put your socks on first, and then you put your shoes over that. So we're calling it shoes on socks. So there's a sequence involved. And if you turn the sequence around, you do not have the same result. And the shoe, you're putting the shoe on not just the foot, but the foot with the sock on it. So the sequence makes all the difference, and as we can see here, you get a different answer. Now, let's look at a specific problem. Suppose we have f of x equals 2x plus 3, and g of x equals x squared. Now, what we're going to do is find f circle g of 3. In order to do that, another way of writing this, as we saw above, would be f of g of 3. Now this tells me the sequence. Now the easy way to remember is whichever function is closer acts first. So in this case, g acts first. What does that mean? It means to plug 3 into g. Let the function machine do its thing. So what we're doing here, this means we're going to find f of, all right, what does g do to 3? Well, according to this, it's going to square it, so it's going to be 3 squared. Notice I'm putting the 3 squared right in here where g of 3 is, because that's what g does to any number. It squares it, so I'm squaring the 3. So basically, this tells me that the number I'm plugging into f is not 3, it's 9. So now to find f of 9, I plug 9 into f, so that gives me 2 times 9 plus 3, which is 21. So both functions did their thing. My answer to that was 21. The next problem I'm going to do is using the same functions. Let's find g circle f of not a particular number, but say x this time. What this means is, I like to write it in this form because it's a lot easier to work with it. It makes more sense to me, but you don't have to. You can work with it just in this form. This means g of f of x. Now notice in this case, we're not going to get a specific number for our answer. We're going to get an expression because instead of plugging a particular number in, we're plugging in x. Alright, so this means f is going to act first. What does f do to any x? Well, it says here to multiply it by 2 and add 3. So for any x, f of x is this expression. So that's g of 2x plus 3. To do this, I plug this whole quantity into g. So this means, since it says g of anything, it means square that thing, this whole quantity is taking the place of the x here. So in other words, g tells me to square whatever comes into it. So basically this is going to be 2x plus 3 quantity squared. And of course, that is going to give me 4x squared plus 12x plus 9. And that is how you apply the composite function. In this case, we did g circle f of the variable x, so we got an answer involving x. If we had plugged a particular number in, we would have got a particular number for our answer.